I'll get started. What do we mean by reprojecting? Reprojecting a raster means a lot more than just reprojecting. It's a key, it's supposed to be the point. From one spatial reference system to another. We're not just talking about converting degrees to meters. Reprojecting is a big task and it can include a lot of other subtasks, which are like resampling, cropping, doing data arithmetic, and doing linear stretching. There's a lot of resampling methods we can choose from, and those include median, mean, min, and max, bilinear. Welcome, everyone. Welcome. And near, and many others. So the purpose of this talk isn't just for me to talk, but it is to share lessons learned that you might be able to apply in your own use cases. It's my hope that you apply these lessons in your project and furthermore be inspired to seek other optimizations and contribute those to the presentations at FOSS4G. This is the outline of the talk. We're going to talk about turbocharging reprojection, making our min and max calculations. Welcome. Making our min and max calculations. Making our min and max calculations faster. Pre-sampling, a term that I just Googled today, but I think applies in this case. Smart caching, because smarter is always better, but not always. Planning, and then discussing any ideas you have, and Q&A. We're going to talk about welcome. I should ask everyone who comes in what their name is. Just kidding. Turbocharging reprojection. We have an example here on the left. You see a conic equal area raster. And on the right, that raster has been reprojected to a web Mercator tile. You can see that there's a lot of rotation when you compare the different projections. And that'll be one. When you reproject, you are fixed to a square grid of pixels. And so when you rotate it, it's not actually a clean rotation. You gotta then make a choice for each pixel. You'll say, what color is this pixel? What color is this pixel? And it's not a one-for-one comparison. So you have to make a choice. And that choice is called resampling. Here's another example. When we're reprojecting this raster from UTM to a web Mercator tile, and just a side note, realize there's even more nuance to different UTM zones. So for the sake of this presentation, we're just kind of simplifying things. When you're reprojecting, you see that it's much cleaner of a reprojection. So this was the previous one, and then this is the UTM, the web Mercator. So you can see that for this raster, and for this example, welcome, come on in. I hope you ask good questions later. Okay. You can see that the rotation almost doesn't even matter in this case. So does the rotation matter? Yes and no, rotation is important, but it doesn't actually impact the output. There's a one-for-one between these pixels and those pixels. Welcome. If the rotation won't actually change the result, you can safely ignore it under certain circumstances. If the error without the rotation is less than half the pixel size, we can probably safely ignore the rotation because it's not actually going to have an impact on the result. So we can leverage this principle and make things faster by just dropping rotation. So we can take it even further, and does the projection even matter? Do we care if it's UTM or Web Mercator? We just care the mapping between the pixels on the left and the pixels on the right. Yes, we need to know about projections, but our function doesn't need to care about how wide and tall the Earth is. It doesn't need to care about where latitude is. It just needs to be able to do a simple function, convert from the left image to the right image. So we can speed up our projection of the coordinates from the input to the output by replacing our projection-aware function with a simpler projection-unaware function consisting of just offset and scale. Again, this is under certain circumstances. The fewer parameters or factors, the faster the calculations will be, just for computers. So in this case, dumber is actually faster. It's not good to be too smart because we don't need to be too smart. For example, if we're converting from UTM meters to degrees, we'll still output degrees, but the function in the program doesn't know their degrees. They just know their general units that we want. And you don't have to remember intermediary information you use in your function, like the circumference of the Earth. It's not important, or the radius degrees. You just need offset and scale. That can also sometimes be referred to as the bottom left or the top left corner of the bounding box, and scale is sometimes referred to as pixel size. In more technical terms, this is the reprojection function that we are fitting things into. So if you go back and you're looking at UTM, Web Mercator, these things are complicated. This requires like a university degree or just a lot of effort on the personal self-learning to like learn all these things. And but it all just comes down to this function. And if we write a program that will make this function for us, then we're in a good place and things are going to go fast. I'm not going to go into all the details there. Just trying to keep it at a high level. Proj-turbo is a JavaScript library that implements this algorithm that we're talking about, this principle that we're talking about. It finds a simpler alternative to a given reprojection function bounded by a certain extent. Furthermore, this implementation, you don't even need to know what the projection is you're working with. You just need to give that projection function to Turbo, and then it's going to run a sample, a test of points, and then from those points deduce what that offset and scale should be. And the steps are there. We're going to reproject our points. Then once we've reprojected, and by points, it's kind of like the corners in the centers of the pixels. And then we're going to calculate that bounding box or the extent. So now we know like what part of the world we're looking at. And then we can use the distance of these points from the origin, whether that's bottom left or the top left, and find out what's the ratio of the units between the first and the second raster. And then finally, before implementing it, it's good to then test and make sure that turbocharging can apply to your use case. If you're dealing with highly rotated rasters or skewed conversions, then it might not apply. So we can take this even a further step, which is completely jump out of the model space or the coordinate space. So when coordinates are talking about degrees or units, we don't even care about degrees or units. We just want to map from one pixel to another. So under circumstances that we discussed previously where there's not a large skew, you can just have a function convert from the row and column of the left image to the row and column of the right image. Okay, so now we're going to move on to the next section. How much time do we have left?
9 minutes.
9 minutes. Okay, I'm going to go a lot faster then. No pun intended. Resampling min and max, that's like extreme values, your highest and your lowest values. And so if we are resampling, we have to make a choice. So we have this pixel in this output raster, but it overlaps 4 other pixels in the input raster. So we have to make a choice. Is it going to be, in this case, a 1 or a 0? If we're doing max resampling, for example, if we want to figure out, is there wildfire in this pixel, we want to choose the highest number. Another example is if there's flooding in a pixel, and we want to know if there's flooding in that area, we'll want to pick the max value probably. And the principle here is that we can just stop reading values once we encounter the highest or the lowest possible value. Like if we start reading here and we hit 1 on our first, we start and we read this one first, then we know we've already hit the highest value, so why read the other ones? So we just apply that principle. And in case if you have 8-bit unsigned integers, 0 to 255, which is a lot of like JPEG PNGs will be like that. Another raster thing for visualization, we can just stop calculating the min or max once we hit that 0 or 255. So, if you guys want to take a photo, now would be time to take a photo of this one. But in the interest of time, I'm not going to keep that long. Okay, so now pre-sampling. Pre-sampling is doing a quick little sample before we do the actual reprojection. In a 5 by 12 by 512 standard web Mercator tile, you're going to have 262,144 pixels. If we only resample 100 of those just to start, it's going to take just a couple milliseconds, and we're going to learn a lot of information. And then we can use that information to make a better choice about how we proceed from there. We can learn about whether data is discrete, continuous, and how large the set of possible values are. So smart caching. Smart caching is built on top of the idea of like a cache hit rate. For example, if you have a high hit rate when you prefer popular songs or listen to the same song on repeat. I have a friend, I'm going to say his name, he's not here actually, but he likes Taylor Swift. So he should just download the Taylor Swift song so he doesn't have to keep hitting his Spotify service every single time he plays them. But I don't like Taylor Swift, and I generally don't listen to the same sort of popular music that the rest of the world listens to. So my cache hit rate is going pretty low. So smart caching and pre-sampling work together. If we pre-sample, we get ideas about the distribution. We can also predict the cache hit rate when we encounter a pixel, and we can just process that value from the input to the output just once and save it, so when we encounter it again, it'll be there for us. This is the example of when I take a photo of when should I cache. Okay, cleaning. The large principle here is basically that we want to get a little information about what we're going to do before we do it. And this language is inspired by SQL query cleaning. And there you go. So the main takeaways is pre-sample your data. A little sampling up front can save you a lot of time later. Don't be afraid to break the rules. Don't be afraid to just forget about rotation and skew. But you have to learn those rules first in order to know when it's safe to break them. Or use a program that does that for you. Okay, here you go.